You can think of a Python list as a function which takes a number I, and we'll call that input to the function a key, and gives you an object, which is the ith element of the list, which we call the value for the key I. But sometimes we have data which is naturally indexed by something other than an integer. For example, let's say you're trying to represent a phone book in Python. A phone book means an association, a mapping between names and telephone numbers. And we refer to the names as the keys in this mapping and the number corresponding to a name as the value corresponding to that key. Now we could represent such a phone book just as a pair of lists, one list of names, one list of numbers, and we could maintain the convention that the ith number in the list corresponds to the ith name in the second list. But this isn't a great solution. It's easy to make mistakes when you work with a data structure represented in this complicated way. It's hard to make changes because you have to remember that if you change the ith element of one list, then you have to change or delete the ith element of the other list. And it's hard to understand the corresponding code because it will involve these integers which don't really have any intrinsic meaning relative to the data you're representing. So it would be much nicer if we had a data type which allowed us to index data using something other than an integer. A Python dictionary, which is sometimes called a map in other languages, Java for example, is a type which represents a function from keys to values and in which the keys can be things other than just integers, as in a list. There are other reasons to introduce dictionaries like this to do with efficiency, but that's beyond the scope of 0011. Roughly speaking, dictionaries allow you to perform operations like adding and removing keys and fetching the value associated to a key very quickly, even when you have a very large number of things in your dictionary. So let's look at some examples of how we can create dictionaries in Python. In the first code cell here, we have the creation of an empty dictionary, and you can see we use curly brackets to represent dictionaries in Python. And on line 2, we create a dictionary which has some keys and values already. So the dictionary is called E, and it has the key A, which is associated to a value 1, and a key B, which gives a value of 2. So you should think of E as being a kind of function where it sends the input, the string A, to the output 1, and the input, which is the string B, to the output 2. And we refer to A and B as being the keys, and 1 and 2 as being the corresponding values in that dictionary. When you've created a dictionary like this, which we do by running the code cell, we can then retrieve the value for a given key using a syntax that looks a lot like when we accessed a particular element of a list. So instead of using E and then square brackets 1 to get the first element of E, we use E and then in square brackets the key B, and this will give us, when I run this, the value 2. Similarly, if we wanted the value of E corresponding to A, we can do it like this. Another way to create entries in a dictionary, rather than just creating them when you defined the dictionary variable, is to do this by assignment. So at the moment D is an empty dictionary, and if we want to put some values in it, perhaps to represent the phone book I was talking about earlier, we can do this simply by assigning to D, and then square brackets, and then the key to which we want to assign our value. So if I run the next code cell, which sets D of UCL security equal to the string 222, then now our dictionary D has a single key, which is the string UCL security, which is associated to the value, the string 222. And if we want to retrieve the value for that key, we do it with the same way we did a couple of code cells ago, like this. And you can see we get as an output the string 222. Don't be confused by the fact we used double quotes to define the string and we got a single quote outside. Single quotes or double quotes makes no difference. They're both just ways of expressing the fact that you've got the string 222. If you try to get the value of a dictionary for a key which hasn't yet been assigned, you get an error. So here we are trying to ask the dictionary D for the value associated to the key UCL security, where this time UCL security is all in lowercase, all small letters. Now in Python, the string u, lowercase u, is different to the string uppercase u. So this is a key for which we've not yet assigned a value. When I ask for the value for that key, I get a key error, as you can see. And when you get a key error like this, it means that there is no value yet associated to that key. If you want a value for UCL security, you'll need to assign it explicitly. Now there is a subtlety in Python dictionaries. Values for a Python dictionary can be anything at all. They can be any type whatsoever. But keys have to be what are called hashable types. That's a limitation imposed by the way in which dictionaries are dealt with internally. The definition of a hashable type is beyond the scope of MATH0011, but any immutable built-in type is hashable. So you can use strings, numeric types, and tuples whose elements are strings and numerical types as keys for your dictionaries. You cannot use mutable built-in types like lists or dictionaries as keys for a dictionary. In the next cell, we're going to define a value, which will be the list34, associated to the key, which is the tuple 1, 2, in our dictionary D. There's absolutely no problem in doing this, and we get no error when we do so. That's because a tuple containing integers is a hashable type. But on the next code cell, we're going to try to define a value 3 associated to the key, which is a list 1, 2. This is illegal because you're not allowed to use lists as dictionary keys. You'll see what happens when I try to do this is I get a type error saying that list is an unhashable type. The meaning of this is you're not allowed to use lists as keys for dictionaries, and the reason, technical reason, is that lists are not hashable types. So in general, all you need to remember here is that the only things that you should use as keys for dictionaries are strings or numeric types, so numbers, integers or floating point numbers, decimal numbers, or strings. Those are fine to use as keys, but you cannot use lists or dictionaries. You can use tuples, but only if the elements of those tuples are, again, strings or integers or other numeric types. Or tuples, as long as those tuples obey the same rules. So it's a bit complicated, and it's best to stick with simple examples like strings or numeric types or simple tuples as the keys for your dictionaries. Now you can get you can remove keys from a dictionary using the command del. So here we use del and then d and then in square brackets UCL security to remove this key value pair from the dictionary. Once I do this, and you can see I've made a typo here. The problem was that the key actually had a capital letter there. That's better. Once I do this, then I won't be able to access the value associated to that key anymore. I'm going to get a key error when I run this final code cell. So once you run del and then d and then a key, it's then removed, forgotten by the dictionary forever, and you can't access it again. So let's put it back. So I hope one useful thing at least you learn from this video lecture is that if you want to get hold of UCL security on an internal phone at UCL, you should dial 222. Okay, we've put it back. Now let's say we want to know what is in our dictionary D. So what keys does it have? You can do that with d.keys. So this will tell you the list of keys which this dictionary has. And if you want to know whether a value associated to a particular key exists, you can use the keyword in. So if I want to know, does my dictionary D have a value associated to the key UCL security? You can do this with UCL security in D. This should give me the answer true because it does have a value associated to this key. I get the answer true. But if we type something else, so ABC, this is not a key in my dictionary so I'll get the answer false when I run this.